Good morning, everyone. Can you please confirm if you can hear me? Let me ask a quick poll question. Awesome. I guess everyone can hear me. So, on Friday, we posted some questions on our social media channels, and many of you responded. So, what we are going to do is we are going to pick a random winner and then we are going to give them a surprise gift. So, let me share my screen and we can do so. So for the quiz that was conducted on Friday, we had about 188 different participants. So out of this 188 participants, we are going to randomly pick one person. So to do that, I am taking the help of Google's random number generator. The way it works is all I need to do is give the range, minimum and maximum, and click on generate, and a number would be generated. So what I'm going to do is the max is 188. So just to see if it's working properly and to show you guys it's purely random, I'm clicking it multiple times. So let me look at the range. The maximum number is 188. So I'm going to put max as 188. And the moment I click on generate, a number would be generated here, and the person corresponding to that number is our lucky winner for today. So without any further delay, let's do this. 3, 2, 1, and go. So it's the number 180, which is Supriya VN. So congratulations, Supriya. You are our winner for today. And our team will get in touch with you and will give you your surprise gift. Congratulations once again, Supriya. And what I'm going to do is I'm also going to show you where you can watch the replays. So there is a link on your sticky note. So I'm just going to repaste it again. So if you click on this link, it will bring you to a YouTube playlist which looks like this. And here you can see this is from day 1 all the way till day 19, which is today. So all the thumbnails are done, even the topic names we have included in front of the heading. And if you have not already subscribed to our channel, there will be a subscribe button which you can see right next to our logo here. So please click on that subscribe button and you will be notified whenever we post any new videos. So with that, Bunny, are you there?
Yeah, thank you so much and congratulations, Supriya, on winning the surprise gift. So let's proceed further now. Let us do a quick recap of whatever we have discussed until now, and then we shall proceed further. Go back. Let me select AI and deep learning. And this is what is a mind map that we have. For people joining in after a weekend, you might find it very difficult, because you were probably in holiday mood. So let's do a quick recap here. We started off by discussing about CRISP-DM, which is cross-industry standard process for data mining, which includes understanding the business problem, creating the project charter, recording the objectives and constraints, Then collecting the data. We have the various data types. We discussed about these. And we understand about the primary data source and secondary data sources. Then we have data cleansing, preparation, exploratory data analysis, feature engineering, in which we have data cleansing, preparation, which is also called as data munging or wrangling. Post that, we have exploratory data analysis, descriptive statistics. Then we have feature engineering. Then you have data mining. Even before we proceed further, we understood about deep learning primer, what is contained in an artificial neuron, what are the two components, and what are the various activation functions which are possible, what are the various optimizers which exist, what are the various deep learning libraries which exist. We discussed about all of these techniques. And we discussed about mathematical foundations, deep learning challenges and practical issues. We discussed about bunch of those. And then we moved into data mining, machine learning. Within this, we discussed about multi-layered perceptron, and then we discussed about convolution neural network. How do you build a convolution neural network? How do you build a recurrent neural network? What do you mean by bidirectional, deep bidirectional, all of these? And then we discussed about long short-term memory. Then we discussed about gated recurrent units. Okay, and then we have to discuss about the other things in a theoretical manner. We'll only be discussing about theory pertaining to all the other algorithms so that we complete this exercise. We will not be having the time and luxury to run the other algorithms, the code part, etc. Will not be able to do that. But theoretically, we will be discussing all the other things so that you all are also clear on what we are learning. Having said that, I'm going to switch to Spider, and we are going to discuss about a few more things pertaining to a few advanced stuff. I'm going to discuss about those in a moment. Okay. Let me see on whether LSTM part is comprehensive or not. If it is not comprehensive, then I will have to, yeah, I think this is fine. Okay. So one more thing, as promised, we have the code and the datasets uploaded until recurrent neural network, because that is what was discussed. Okay, and gated recurrent units, autoencoders, RBM, DBNs, GANs, reinforcement learning, all of these we are going to discuss theoretically. Okay, and also there will be a few advanced things that we are going to discuss today. For those things, anyways, you can make use of the videos which are being recorded. You'll have lifetime access to the videos, so you can watch the videos and understand more. About the code, if I were to use any. And There will also be another option which will be here, which will get enabled. Tomorrow I will briefly walk you guys through that. Here, certificate option will get enabled. Okay, but we will not enable this for everyone at one go because that's going to crash our system. So what we will do is in chunks we are going to enable this, maybe for 100 people per day in that way. So for the next, I think 10 to 15 days, we will be slowly and steadily enabling this link. When you click on this link, what will happen is something that I'll discuss tomorrow. There'll be two links that will pop up wherein you have to give review on what did you like about the training, okay, and what you didn't like, if you didn't like any, and then you can give your rating here. Once you provide your rating, you will be able to download your certificate, right? Feedback is for us to benefit, and we will take that those feedbacks forward. All right, so I think we are good to proceed further. And also, people who have learning management system access, we are assuming they are attending our sessions. We will also cross check at the attendance sheet, and they all will be provided access to download the certificate. And people who have joined in between after missing 2 or 3 classes, we should not be doing injustice to them. So we will give them a sheet to register. Once they register, we will provide them a certificate directly. But for them, it'll be a different process. We cannot provide you with learning management system access. Okay, but we will see on how to deal with you. We will look at the attendance in the backend. We will look at how many classes you have attended. And if it is really logical for you to be given certificate, only then we will be providing you with the certificate. But then you will have to give the reviews for us on how was the training and all that. So we'll discuss about those things later. Now let's get into the programming part of it, wherein I need to discuss about two things. One is the text generation part of it. Another thing is about a tensor board. These are the two things that I wish to show you. So let me come here. This. Let me take this. And then, okay. So this code will not be uploaded on our learning management system because this will any which ways be available on the video. You can use it. I think before moving there, I need to show you something about Tensorboard. To show you on how Tensorboard works, I need to once again get hold of a code which might be related to a simple uh, model here. Let me choose a CNN model, and I'm going to see how we can use this code to explain you a specific technique called as Tensorboard. Okay, just give me a minute while we get started. Just give me a minute. Sorry about that. So yeah, there are only 2 more days to go, right? We will have fun, no worries. So welcome to today's session, and we are going to discuss about Tensorboard. Tensorboard is a visualization framework, data visualization framework. In this specific framework, we are going to discuss on how do I visualize the progress of the algorithm which is being run. When an algorithm executes, we should parallelly be able to visualize on what is going on. And that is exactly what we will be doing. So very simple. After the end of each epoch, maybe you want to monitor the loss, or maybe you might want to monitor the accuracy or various other things. And we are going to visualize the progress epoch after epoch. We are going to visualize using Tensorboard, which is a browser based visualization tool. Everything which happens inside a model can be visualized. You can visualize the metrics. You can also visualize the model architecture. Then you can visualize the histograms. You can visualize the gradients. And you can explore embeddings, embeddings in 3D. When you run an RNN, you can do that. So rather than this, I think it is better for me to make use of RNN code itself so that it's easy for me to show you the progress of the Tensorboard. So I'm going to say import the IMDb dataset. You're going to load the data until I think optimizing it's fine. So let me copy this code. And let me choose one-dimensional convolution neural network. So here we are going to import IMDb. Let me also import Keras. We are importing the IMDb dataset. We are going to import the sequence because you want to sequentially give the data. Say you want to select maximum of 2000 features, and maximum length of each review is going to be restricted to 500. Then I'm going to load IMDb dataset with the maximum features as 2000. Then we do the padding on the training and test data. Why? Because a few of the reviews might be, okay, let me again do this. You imported this, you imported IMDb, you imported pre-processing and sequence. Where will we use that sequence? I'll let you know. Maximum features is 2000 means you want to use only 2000 top words. Maximum, I mean 2000 words which have been referred to maximum times. Maximum length is 500. Okay, so that means if you have a movie review which has 800 words, you're going to restrict it to 500. If there is a review which is restricted to which has only 250, then another 250 will be padded with zeros. So you are taking the sequence and you're padding the sequence. For that purpose, we have this. And you have the training data and you're taking maximum of 500 words in each and every review. You have the training data and you have the test data. When you take the data set from IMDb and when you say load data, it has the data in this format, train and test. So when you load it, you're taking training inputs and output, test input and output. And then you take the data. So let me remove the sprint, which is not needed. I'm importing a few more, essential modules such as sequential, layers, RMS prop, whatever we feel is important, we are going to load those. Then you're defining sequential. You know for a fact that whenever we have textual data, that textual data cannot be directly supplied to your network. So you come up with embeddings. So when you have textual data, the first thing is you come up with tokens. Tokens means each word is a token, or each alphabet character can also be a token. Then these tokens are converted into numerical tensor. And you're saying that you're taking maximum features of 2000 words which have been referred to maximum times. And each of those words would be represented using 128 vector. So your vector size will be 1, 2, 3, 4. In that way, you'll have 128 different numbers. And you're saying the input data which is supplied should be of maximum 500 words. This process of converting textual data into tokens is called as tokenization. And the process of converting your textual data into numeric tensor is called as vectorization. And the process of converting tokens to numeric tensor is done using either one-hot encoding or it is done using word embedding. Okay, so either using this or this. And in word embedding, we discussed about word to vec, and we have also discussed about glove, global vector representation. And we have also referred to how to use pre-trained model. These are all pre-trained models, pre-trained embeddings. How do we use that when we deal with textual data? And while we do this, or let me go back here and say that, okay, once you are done with the embedding, once you get your tokens in tensor format, you then take that and supply as an input, supply these as input to either your RNN model. When I say RNN, LSTMs and GRUs are also part of this, or you have a one-dimensional convolution. One D convolution there. This is what we do. So you take the data and then max pool, con1d, then global max pool. Okay, here the difference between max pooling and global max pooling is something which is often asked in interviews. Often it is used in interviews. So the difference between these two is that if you have an image which is of say 5 by 5, and if you take this max pool of say 2 by 2, and if you apply on this, if you apply this on this patch, then you take the maximum of these 4 values as output. When it comes to global max pool, the pooling layer will be the size of your input. Here also you'll have 5 by 5. When you have 5 by 5 and when you apply on this, you will ultimately get a single value out as an output. That's global max pool. These are a few things that we have already discussed, but I'm throwing some more light so that it's clear for you guys. Okay. And then we have a summary. Let me load this. Okay, you have the embedding layer, con1d, max pool. Max pool is not adding any new weights. And global max pool is also not adding any new weights. Sorry, one second. Views and ebook. Okay, sure. And then we are compiling the model. Whenever you want to compile the model, you give your optimizer the learning rate. What is the loss that you want to use? Because this is IMDb dataset. We want to analyze the movie reviews and we want to classify on whether the movie review is positive or negative. Hence, we are using binary cross entropy. It's a 2-class problem that we are dealing with. Hence, binary cross entropy. Okay. And then even before you run your model, you have to go to your directory, os.get current working directory. And you need to go to this path and create a folder. Let me go here to users, Bharani, and then here I think there will be a folder. Yeah, my directory. That's the name of the folder. I'll delete these things for the time being. So I created this folder, my _ dir directory. Once you're done with that, we have to launch the Tensorboard. How do you launch the Tensorboard? You launch the Tensorboard by giving a callback. You'll say, let me give a callback function. And here you say that within Keras, there is something called as callbacks, within which there is something called as Tensorboard. You have it here, Tensorboard. And within the Tensorboard, You're saying that you want to log the results of each and every epoch in your directory. Is that the name? No, it's my underscore dir, my directory. I just gave such a name, that's it. Comma. You can give histogram frequency as 1, and you can say embeddings frequency equal to 1, meaning you want to record the embeddings data, you want to record the activation layer histograms after every epoch. After every single epoch, you want to do that. That's the meaning of this. So let me run it. Okay. Warning messages can be safely ignored, not a problem. And let me run for 20 epochs, batch size, validation data. And here you also have to provide your callbacks. And you're saying, I want to use this callback. Okay. And you run it. But before we run it, I want to enable Tensorboard. To enable the Tensorboard, which is a browser-based visualization, you need to go to Anaconda, go to Environments, do a drop down, say Open Terminal. Here you say Tensorboard log directory is my directory. Enter. It has enabled now. Okay. Tensorboard 2.2.0, and it can be accessed using this. So you can do a selection. I shall mark only this and then copy that. And I'll go here to the browser, and here we can open it. Yeah, no dashboards are active for the current data set. Now, if I start running this, it will start. Oh, we didn't compile, my bad. Compile callbacks history. So epoch 1 started, and let me refresh and see. Wonderful. This also got started now. Okay. Only the graph is visible. These are the things that you created. Embedding. Then you created convolution 1D, max pool, conv, global, and dense. This is exactly the main graph. And auxiliary nodes are you have given an input and this operation is going on. After the first epoch is done, you see the loss, accuracy, validation loss, and validation accuracy. So now if I refresh this, you'll be able to see results of epoch also. Yeah, there we go. So epoch 1 is complete. Training accuracy is 0.5418. Validation accuracy is 0.5812. Is that the case? 0.5418 and 0.5812. Wonderful. Now you have various other things. Okay, second epoch is done. See, automatically it is getting refreshed. And you have the graphs. You'll have the distributions of the words. You'll have histograms. And yep, so this is how you can visualize. Let me. So the good part is real time you are able to track on what is the progress of training and validation. If at all, somewhere the data is not moving ahead properly. For example, say the difference between your validation and test accuracy, if it becomes like this, okay, or training increases, validation decreases, then you know that you need to stop. It's converging. After that, it will diverge. If there's a huge difference between training and validation, you stop. You simply go here and click on this red icon, and the operation will halt. This is how you can monitor the progress being done. Okay, we shall wait until the 20 epochs are done. Okay, so that I might also show you on how this convergence appears. Let it complete. We shall wait for the number of epochs to complete. It's 9 epochs. If we wait for another maybe 1-2 minutes, we will be done. So let's wait until that is complete. Yep, it's converging. Let's also monitor the progress here. Loss already started diverging in a big way. Okay, so we'll see. We'll wait for these 20 epochs to get complete, and we will monitor the progress here. Okay, it's 11 epochs down. Actually 14, but it's getting updated in a slow manner. That's okay. The convergence, the divergence started with respect to loss also. So we'll look at both. Training and test data. Here the loss of validation is increasing. Here it is decreasing. So maybe if given me an opportunity, probably I will maybe stop at 60 epoch. Maybe after that the loss is diverging. And but when I look at the accuracy values, as long as both increase, we are kind of okay. But loss also should behave in a similar fashion, but that's okay as long as accuracy is impacted. So both are increasing, but if this stabilizes or reduces, which is validation accuracy, then we have to stop. Until now it's fine, because usually in real world you run hundreds of epochs and you cannot sit in front of your system and monitor that. Okay, so you make use of your visualizations. There are many things in this you can visualize. You can get into this. There are many things which are available. You have what if analysis also, which is available. These are all advanced analytics parts. Okay, we are almost done with 20 epochs. So that is how you make use of Tensorboard. Embedding should appear. I'm a little surprised on why that's not appearing. Let me run it. Why is embedding not being run? So this embeddings, it will run actually. Maybe something is going wrong. There is part isn't visible. Anyways, that's okay. Usually you'll be able to see the word embeddings in various ways. You can also save this architecture. This is your architecture, right? Basically, this part. If you observe here, you have your embedding layer and you have that embedding. Next, you have conv one dimensional. You have con 1D. Then you have max pool. And here you have max pool. Then you have con 1D. Here also you have con 1D. Then you have global max pool. You have a global max pool. And then you have finally dense here. Here also you have dense. So the point is, this is the architecture. However complicated your architecture might look, you can save this architecture image also in PNG format. You can actually save it onto your computer and use it for further analysis. You can also get a detailed image. All these are possibilities. Then for hyperparameter tuning, we can make use of automated grid search techniques. So even before I get to the grid search technique, let us list down what are the various hyperparameters which exist. Okay, so that's a question to you all. What are the various hyperparameters which exist? Come on, let's do a rapid fire round here. I request everyone to keep responding. What are the various hyperparameters which exist? Yeah, friends. What are the various hyperparameters that exist? Yes, Jagdish, we can use Tensorboard for all the DL models. Okay, Anil, I think I am. Which part do you want me to maximize? You were asking. I didn't get you. This part? This is a browser. Please don't use your mobile phones. It will not be visible, friends. That's what I've been requesting you all. Learning rate, okay. Humera says learning rate. All right. And Chandrasekhar says number of hidden layers. Wonderful. That's right. Number of hidden layers. Absolutely. And activation functions. Absolutely. Which activation function do you want to use? Okay. And then what else? Learning rate. Yep. Hidden layers. Yep. Majority of y'all are saying number of hidden layers, learning rate. Okay. Dropout. Yes. What should be the value of dropout? That I cannot zoom, Sasanka, unfortunately, yeah, because that's a Windows command prompt that cannot be zoomed, right? So that's a challenge. 1 second. This is the part, right? So this part I'm unable to control and supposedly something to do with mouse, but that's not there. Okay, let me see. Yeah, I think it's working. All right, this is what I've typed. Tensorboard space minus minus log directory equal to my directory. Okay, this is what I've typed to enable the Tensorboard. Then I got a response saying that Tensorboard 2.2.2 is active at this. So I've taken this, copied this, and I've pasted it here. Okay, and then I was able to use it. Hope this clarifies. And then Aparna, I didn't quite get you, but still the graph is not clear diagrams. What do you mean by that? Are you saying this is not clear? Is this not clear to people? Epoch accuracy. I mean, I can zoom it even further if you want. And it gives you the accuracy values of training and test after the end of each epoch. Right? How are the values? Is something that you can explore. Yeah. Then remember gate. No, not exactly Murthy, but dropout. Yeah, I can take it. Initialization of weights, I can take it. Srinivas. Yes, absolutely. So let me go here and let me erase these things. Dropout. Yep. What should be the actual dropout value? Wonderful. I'll take this. Then weight initialization techniques. Wonderful. That is also weight initialization technique. This is also a hyperparameter. Hyperparameter means something that you need to keep changing. These are the various things that you need to keep changing and you'll be experimenting. Learning rate, number of hidden layers. I'm just checking if there is anything better. Weights initial, batch size. Wonderful, Manikanta. Absolutely. Batch size is another hyperparameter which exists. Learning rate, yeah, we have taken that. Cost functions, optimizations, okay, fine. Optimizers is okay. To a great extent, your cost function or loss function is well defined. But again, can I treat this as a hyperparameter? Why not? Yes, sure, because there are different cost functions and loss functions which exist. Then activation functions, I have, yep, selected those. Weights, yes. Cost functions optimized. Size of each, yeah, batch size. Number of epochs, wonderful. Key thing, number of epochs. And what else? Different windows. What do you mean by that, Aruna? Different windows. Number of hidden layers. Okay, that is taken, I think. Number of neurons. Yeah, that I would certainly consider. Number of hidden layers and number of neurons within a hidden layer. Point taken. What else? Batch size, dropouts, adjust the weights and bias. Okay. Loss function, batch size. Hidden layers. Yep. Optimizers. Making the training set. Activation threshold. Data augmentation is not a hyperparameter. It's a regularization technique. Venkat Kiran. Oh, sure, Jagdish. I've done it, I think. Training and test ratio, mini batch size, changing weights. Yep. Okay. Maybe Aparna, because of the internet issue or something on those lines, could be. How can you save model? No. That for that, Jagdish, you need to run function. Okay. In the code, you have to write a function. From Tensorboard also, you can explore that. Integer or float size? No, it should be always float, Nagaraj. Always float, huh? Padding. Yep, maybe. Yep, I can probably consider that also as an optimization function. Or sorry, as a hyperparameter. What amount of padding you want to do? What is the amount of pooling you want to do? What is the stride that you want to take? Okay, and then yeah, momentum, Nestrov momentum. Agree with you guys. What should be the momentum parameter value? Maximum frequency words. Wonderful. Where are all these answers coming from? Great. I didn't expect, frankly, these many responses from you guys. Very good. Amazing. So here, to a great extent, the cost or loss function is streamlined, right? If it is, but then I think I can also give you various details of various loss and cost functions, but I think now is not the right time because again, I'll be digressing a little. So that's okay. So the point that I want to drive here is that while all these things are the values that you keep changing to keep experimenting, okay, all these hyperparameters, there are a few things which you can readily experiment. One is learning rate, another is batch size, another is the number of hidden units or hidden layers. These are a few things which people often keep experimenting using grid search techniques. Grid search techniques. We are going to discuss about grid search techniques, and these grid search techniques are techniques which can be applied to all the algorithms. It's not just for neural networks, but it is for all the algorithms basically, and we will certainly discuss about these in finer detail. And I am going to use a program here, which is African crisis. In this data set, you have details on given various economic indicators. Will any country in Africa get into banking crisis? Will they get into some kind of financial crisis? Right? And that's what we need to discuss here. So even before we discuss that, let me quickly tell you that cost function and loss function, we'll get to grid search techniques. If you have an output variable which is say continuous, obviously you can use mean error, mean squared error, but majorly people use mean absolute error because of the interpretation. You can interpret the results. Okay. So yep, I can say that it's a hyperparameter because you need to keep changing various values. And But changing mean error to mean square error or absolute error would not change the end result significantly. Okay, it doesn't change the end result significantly. So maybe I would say 50-50. You might want to try out, or you might want to say, hey, whichever loss or cost function we used, it doesn't matter. Also, there is an additional thing which is called as Huber loss. This is also another loss function. When it comes to regression techniques, sometimes people use it. I don't use it, but I've seen people using that, and people say that, what, that is what I like, so I'm using it. Fine, that's okay. Next, if your output variable is discrete in two categories, you use what? Binary cross entropy. Binary cross entropy. However, there is also another technique called as Hinge technique. Hinge is another loss which people use for classification purpose. If you have more than two categories, discrete in greater than two categories and two categories. Okay, if you have greater than two categories, then you can use categorical cross entropy. And when you have textual data, when you have text data, people use either cross entropy or they use something called a scale, divergence, and people also use something called as cosine similarity. These are all the various techniques. So, I mean, we can safely say that maybe you might want to consider this as a hyperparameter. Hyperparameter is that parameter which you keep changing for your experimentation purpose. Okay, and then we have this grid search technique which exists. Grid search technique is amazing, and there are many such techniques which exist. So let us understand in this context. I'm not going to run line by line. Neither will this code be provided, because all these are the things which are out of scope, but I'm adding it for your own benefit. Okay, so there is something called as African crisis. Okay, forget about the pre-processing, because I want to directly get to the point and discuss about how we can use the grid search techniques. Okay, just run this. Now what I shall do is go here, and I think there is something called as auto ML. I will load this, and we'll discuss about this auto ML stuff here. Okay. Now here, what we are going to do as part of auto ML is two things. I'm going to import train test split and grid search cross validation. Grid search is a technique wherein you take all the possible values of your hyperparameters. Okay, so if I were to run this, okay, and then here we have the model that we are defining, and there we go. Okay, and we are using a wrapper. Wrapper is a function which will help you wrap your Keras or TensorFlow around the scikit-learn libraries or other libraries. One library can call in other library functions using wrapper. So different libraries exist, right? So all those different libraries can be actually combined together. One library can be used within another in this manner. And here I'm taking different values. Learning rate, you have different values. Batch size, different batch sizes. Hidden layers, you're trying out various values. You can try any number. Okay, this is just an illustration. Here you have 4, here you have 3, here you have 3. 3, 3. You can even take 10, 10, 100, 100, how many ever you want. Doesn't matter. So how many combinations should you try out? If you experiment with this, then you have to try out 36 different varieties. 4 3s are 12, 3s are 36. 36 different configurations. Hyper, parameter, configurations can be experimented with. And I'm creating a dictionary of learning rate, batch size, and hidden units. Okay, and you are going to run the model. So let me do this. And we have a grid search cross validation. What does this cross validation do? If we are saying cross validation equal to 3, then what it does is it is going to split the data into 3 parts. Part 1, part 2, part 3. And then you run different folds. Fold 1. In fold 1, you choose part 1 and part 2 as training, and part 3 will be your test. Then you have fold 2, in which you choose part 1 and part 3 as training and part 2 as test. Then we have fold 3, in which you choose part 1 as test, part 2 and part 3 as training. And when you train on these two and test on this, you get accuracy for the first fold. Here you'll get accuracy for the second fold, and you get accuracy for the third fold. Then what do? You take an average of all these. Okay, you take an average of all these 3 accuracy values. That is what we do. So that's what we do. N jobs equal to -1 will ensure that all your processors are used for processing the data. All of your processors will be used. That means if you have a dual core machine, both the cores will be used. If you have quad core computer, then there'll be 4 cores. Core 1, 2, 3, 4. So parallelly you can run your data through those. Okay, that is what we are saying as part of jobs equal to -1. Let me also invoke the GPU and see whether GPU is going to work or not here. So you define your grid and then you fit the model. Let's see what's going to happen. So it would take some time. Yeah, GPU kicked off. It became 3%, then it's reduced. Let's see. CPU usage is reaching 100%. Did you observe that? That means it's not moving to GPU. We have to do something else. Okay. If you see here, CPU reached 100% while this was running. So that means your GPUs are not triggering. And then you calculate the mean standard deviation of all the parameters. You print here all the results. So these are all the combinations. What is the mean accuracy? What is the standard deviation? What are the various hyperparameters that exist? Batch size, hidden, learning rate. But this will be very, very exhaustive and very time consuming. Whatever you give here, all the combinations will be experimented. And then when you want the best result out, we just run this line and then it is going to show you the best result. Best result is 0.979, wherein you have batch size of 100, hidden units is 8, and learning rate is 0.02. Since this is extremely exhaustive, what we need to do is we need to try out different approaches. And there is one approach which is called as random search. Okay, there is one technique called as random search. There is another technique which is called as Bayesian optimization. These are the two techniques which exist. Okay, we will experiment, we will try out the code pertaining to this, and Bayesian optimization theoretically we will understand, and I am basically fan of Bayesian optimization. On a personal note, I'm a fan of this because I keep running this hyperopt, hyperas and all that, which I feel gives me better result and gives me confidence that I have done something related to, you know, some kind of math calculations. Yeah, but we will get there here and here after the break. Okay, let's take a break and then come back. It is let us be back by 50. Okay, let's be back by 11:50. It's almost 11:40, and then we will continue further.
आपके द्वारा डायल किया गया नंबर अभी व्यस्त है, कृपया
ఈ సేల్స్ పర్సన్కి వీటికి కూడా కావాలి. ఈసీ కోసం
ఎంతంటే ఏమంటున్నారు
ఆడు సోషల్ మన డిజిటల్ మార్కెటింగ్ వెళ్ళి చూసి కీవర్డ్ సెర్చ్ అవి చేసి మీకు బాగుందండి మీరు ఈజీగా చేయగలుగుతారు అందుకు వాడే చేసేస్తాను డబ్బులు అయితే కట్టలేమండి కమిట్ కాలేదు రిజిస్ట్రేషన్ బేస్ మేము ఇస్తాం కావాలంటే 30 అన్న చూడండి ఫస్ట్ అయితే లోగో 30 కిట్స్ ఫస్ట్ అయితే లోగో ఇవ్వండి ఎట్లా మార్కెటింగ్ తీసుకోవాలి 30 తీసుకోవాలంటే లోగో లేదు ఫస్ట్ అయితే మీరు డాక్యుమెంటింగ్ చేసేయండి నేను ఇమీడియట్గా మీకు అప్లోడ్ చేస్తాను
అది చాలు సిఎస్ తీసుకొస్తాను
నేను అదే ఇస్తే కనీసం నాకు టైం ఇస్తే నేను చేస్తానని చెప్తాను మీరు ఈ రోజు ఇవ్వండి నేను రేపటికల్లా మీకు అప్లోడ్ చేస్తాను అది సిగ్నల్ ఇప్పుడు అది చేంజ్ చేస్తున్నాను కలీంకి ఇద్దామని చెప్పాను సుధాతో మాట్లాడితే సేల్స్ కేటీ కూడా వాళ్ళే ఇస్తారు
ఎవరికి ఇద్దామన్నది
కలీం FSGS చేయలేదు ఆగినప్పుడు సో కలీం ఇస్తుంది కేటీ ఇస్తారు ఈసీ నేను కాల్ అయిన తర్వాత డేటాకి కూడా చేసిన చూడు ఉంటుంది అటు ఏదో చేసిన
పంపించే వేస్ట్ నాకు ఓకే దాన్ని Okay, so let's proceed further. And yeah, Srinivas, sorry, I didn't check that. And I just cross-checked with our team on what I spoke. I think nothing was alarming, so that's fine, I think. Live YouTube link, Enoch, are you there? The live YouTube link for that, you need not.
And they're burning.
Yeah, when one of our friend is asking for live YouTube link, I think you just need to go to the YouTube link, right? And it'll be there, no?
Yes, it should be. Let me just check and I'll put it in the
Yeah,
sticky
yeah.
note.
Yeah. I think Monica and our other friends have done it, I think, already. Okay. Yeah, default -1 is, I think, default. Yeah, Shakina. Yep. Okay, when you run that line, what happens, Chandrasekhar? You're getting the error. Now you have to figure out on why that error has come. It's not that easy, Chandrasekhar, that I look at the error and then quickly behave like a Google search engine. That is not possible. Okay. So you have to figure out why that error is coming and then you can proceed further. Anyways, so let's go back to this and let us understand. So here, the disadvantage with grid search technique is that it is going to exhaustively search and try to find all the combinations, batch size, hidden units, learning rate, all the combinations. And doing all the combinations would be very, very exhaustive task. It'll be very time consuming. If you have a huge data set, it would mean days of effort, not 1 or 2 days, many days. Hence, to counter that, we have another technique which is called as randomized search. So in randomized search also, you first define your hyperparameter values. Then you define a dictionary of all the parameter grid values. Then you move ahead with randomized search cross-validation. And in this randomized search cross-validation, we are specifying clearly that number of iterations should be 10. That is the number of trials to perform. Okay. How many combinations of these have to be tried out? Only 10. And again, you want to use all your processors and cross-validation is 3. This technique will be very fast and it will quickly accomplish the task for you. Okay, it's taking a while because it's running all those combinations. Yeah, and then you run this and job done. You have all those 10 and among these 10, this is the best result that one can obtain. This is how it works. Okay. And then you also have something called as Bayesian optimization. Within Bayesian optimization, we use various steps such as you use an objective function, what we want to optimize, you will define a search space which has set of all possible values, all these combinations. Third, you use an optimization algorithm. And finally, you'll have the set of solutions. Out of these set of solutions, you choose that solution which is the best. And there are, when you run different combinations, you get accuracy values in that way for all the combinations. And then here we have taken a mean and standard deviation, right? It's a direct application of the formula. But when you do this optimization technique, there are different ways of calculating the mean of all the accuracies and standard deviation. Right? For example, the technique that is used is called as kringing or Gaussian process. In that way, there are various things, but I don't want to get into further depth. Okay. The only thing that you need to remember is that there is something called as grid search technique which exists, using which you can try out various combinations. Okay. The next thing is automatic text generation. So we have worked for a client called as Astro Avani, which is a Malaysian company, and that is a media channel. The ask that they had was that, do you know what? Can you extract from the web and social media forums the trending topics? And they wanted us to extract the trending topics once in every 4 hours. So once in every 4 hours, you need to extract the trending topics. And these details have to be passed to the journalists of Astro Avani. What would they then do? They're going to look at the trending topics, and using these trending topics, they will come up with a new storyline. And then they're going to publish that so that the news channel is also in limelight. So we started extracting the various links, various articles, and then we supplied to the journalists. They were again spending some time on that and coming up with their own original, so-called original content. But this was also taking some time for journalists to come up with this. So what we have done is we have built an algorithm which would automatically generate text. It would automatically generate the text. And this text would then be used by journalists to quickly review for English or some kind of editor to check whether the grammar, etc. are fine. And then they close it. They publish that. This would automate the entire task. Extract the data, all the trending topics. Using those trending topics as your training data, you automatically generate new text. Right? And this would be an amazing step to work upon. And I'm going to explain you about the logic on how it works, and then I'll run this code. I'll run and stop it, because if I run it, it will take at least 1 or 2 days to complete the entire exercise. Okay. And way back in 2016, movie which was generated, script of which was generated by LSTM, was directed, and that movie was called as Sunspring. Okay, the AI script was automatically generated, and based on that script, people have come up with a movie altogether. Let me show you that. Then you have Sunspring here, movie directed by AI. So look at that. Sunspring in 2016, they directed this, a short film, entirely written by artificial intelligence bots using neural network. It was conceived by BAFTA-nominated filmmaker Oscar Shah. Okay? Amazing, isn't it? And do you know what? There are also images which are generated by AI. So AI generated art sold. And the AI generated art was sold for $432,000. $432,000. Amazing, $500,000. This is what is happening as we speak now. And how does this text generation work? And do you know what? You all must have seen Google's Smart Reply. Smart Reply feature from Google, Gmail basically, wherein if there is an email that you need to draft, it will recommend on what sentence you should have. That's based on this LSTM capability. Of course, there are a lot of advanced techniques which have come in. And Google, of course, is a pioneer in terms of using those kind of advanced techniques. And how does this work? Let us understand this part. So what happens is, say there is a text which says faculty development program on AI is, yeah. After this, what should you get, right? So this is the initial text that we have. And your LSTM model has to automatically generate. This is called as character level neural language model. Character level neural language model. So what you do is you take this initial text and you create a language model. What is a language model? It will come up with a probability distribution for next character. Okay, probability distribution for next character. In this way, it will have the probability values for each and every word. And then you come up with a sampling theory or sampling strategy rather. And you're going to come up with the next sampled character. Out of all these words, which or out of all these characters or alphabets, which alphabet is most likely to come after S? Whichever character has the highest probability, you choose that. Say the highest probability is for U, alphabet called U. So this is sampled next. And this sampled character goes back to your text. Now it will be FDP on AI is SU. Now again do the same thing. Take a language model. Then you do a probability distribution for next character. And then apply a sampling strategy. And this time maybe you get P. So in this way, if you complete, you get superb. slowly and steadily, all the character one after another. And when it comes to the sampling strategy, you have multiple sampling strategies. A naive approach here is greedy sampling. What happens in a greedy sampling? In greedy sampling, you take all the characters or all the alphabets and randomly choose one. Oh, sorry, my bad. So in greedy sampling, what happens is it's more predictable basically. So what you do is you look at all the probability values and choose that character which has the highest probability. Okay, so it's most likely next character would come up here. So here you'll get most likely words. There won't be any surprise element. You'll get most likely words. And another side you have stochastic sampling. Okay, stochastic sampling. Here what happens is in stochasticity means randomness in the first place. Yeah. So you choose randomly on which alphabet has to come next. After S, which alphabet has to come next is randomly chosen. And probability of choosing any alphabet is equally likely. There's equal probability of choosing any of these. And on one side you have the most likely, on another side you have completely random. Can I strike a mid balance somewhere? Yes, you can. And this can be controlled using something called as softmax temperature. There is something called as softmax temperature. This is what has to be used. And here you choose different temperature values. These temperature values can be any range, usually between 0 to 1. 0 means completely greedy sampling, meaning whatever character has the highest probability, you choose that. 1 means complete randomness. Okay, so high temperature means more random, low temperature means more deterministic. And what I shall do now is I'm going to run a piece of code which has different temperature values, and I'm going to run certain number of epochs. After each epoch, the text which gets generated will become better and better. Okay, so I repeat, when you have a text like this, and if you want to generate the next set of characters, you apply a language model which will look at A, B, C, D, all those alphabets, and which alphabet has the highest probability of occurring after S. You choose that using a sampling strategy and then assign it here. So you get SU now. Now again follow the same thing, and the next character, your model might say it is P. So take P. Again follow the same thing. It might say next should be E, next it should be R, next it should be B, in that way. And then you ultimately get superb. as a word. Next word. Then, as part of this sampling strategy, you on one side have stochastic sampling, on another side have greedy sampling. And the greedy sampling is completely deterministic, so you will not get any surprises. Expected results will pop up. And on the other side, you have stochastic sampling. There, completely random results will come up. There'll be a lot of surprise. So amount of randomness will decide upon the surprise. Okay. And here there is no surprise. Here there is complete surprise. And the amount of surprise is controlled using something called a softmax temperature. Sometimes you go beyond 1. You give values beyond 1 and it will be even more surprising. Surprising in the sense those words probably you haven't even heard in your lifetime. That is probably not even there as part of your vocabulary. Those kind of words also might come up. Okay. So I will run this. And after I run this, I'll just quickly look at your questions. I've seen a few questions, but let me complete this. So I'm loading a specific data set, which is in some German to English translation. And I'm going to run this. As I've told you, I might not have, or we might not have the energy, time and energy to try out various things. I will try out maybe only 30 epochs or maybe just 10 epochs just for showcasing it to you guys. And we are trying out with different temperature values, 0.2, 0.5, 1 and 1.2. And then what we shall do is, it will do all the vectorization and all that. So epoch is running, epoch 1. After each and every epoch, you will get some result. So let's wait for just this one epoch to get completed. And then we can see how the results look like. While that happens, I would go here and look at your questions. I've searched in Stack Overflow, value of -1 means there is no restriction with the value of means it can only use one per search. Okay, fine, Shakina. Then this model will automatically predict the next trading result. Next character, yes, absolutely, GVN ready. So complete quickly. It's completing. Wonderful. So it started generating, if you see, for temperature 0.2, it started generating automatically the text. And for temperature 0.5, it's generating. It'll be slightly different, the words. And when you look at temperature 1, it'll be very, very different. Look at the words. A few of the words are very new. And temperature 1.2 will be even more different. Look at that. You cannot even make sense out of that. And then epoch 2. After all the epochs, after each and every epoch, all those temperature values are run. So this way, text can be automatically generated. Okay, just imagine the irony of movie script writers, etc. So for that case, Netflix is heavily relying on these techniques now because they produce a lot of original series. Say they will take they are taking all the super hit movies, for example, Lord of the Rings or Harry Potter, which has a lot of sequences. And then it's letting your AI algorithm generate the movie script for the next movie. If these are all the super hit movies, chances are high that this AI will also generate movie script for a super hit movie. Or maybe this can be again read by the movie writers, script writers, and they can get beautiful ideas. Okay, the only thing is it will be time consuming. See, for second epoch itself, it's taking so much time. And at least you need to run 400, 500 epochs to be able to get something meaningful. Okay, and that's how it's generating again. This is for temperature 0.2. Then for temperature 0.5. Then temperature 1. Then temperature 1.2. And then the third epoch started. So in this way it will run, it will take its own sweet time. While it takes its own sweet time, let us go back here. What is this? Srinivas, what do you want to know? I didn't quite get you. Let me make a note of this. Maybe tomorrow I can touch upon that. DL in intelligent wireless circuits. I haven't worked in this space, Srinivas, but I can do some research and get back to you. Okay, I haven't worked on intelligent circuits and all that. No, I haven't worked on that. But still, I'll see what best I can do in that space. Maybe a few of our team members have worked. I'm not sure. I'll have to check with them. Okay. So let's now move on to autoencoders, which is an unsupervised learning technique. So we are now going to learn unsupervised learning techniques. And we are going to learn about autoencoders, wherein what autoencoder does is, it is an unsupervised learning technique. We need to first understand on what is the difference between supervised versus unsupervised. Supervised versus unsupervised learning algorithm. Supervised learning algorithm means within your historical data that exists, you'll have an output variable and input variables. Unsupervised learning means your output variable is not known. You just have inputs. You just have inputs. If the output variable is not known, if it is known, for instance, you'll have your network and an output like this. You'll have a network like this. And you'll have, you'll move in this direction. You'll calculate the error. I mean, you predict the output. You take the actual value, compare it, and if they are not same, you'll get an error. With that error, come back and update your weights. Okay, again, go to the next row, take your inputs, pass it through your network, calculate the predicted value, compare it with the actual value. If there is any error, take that error, come back and update your weights. You continue this process throughout, right? Because you know what is the output variable here. Whereas when it comes to autoencoders, there is no output variable. So what will you do then? You take your inputs, okay, and you pass it through your hidden layer. Then you don't know what is the output. Output is unknown. Since the output variable is unknown here, you want the same input to come as an output. So you want to reconstruct the same thing yet again. So you move in this way. Okay. Each network is connected to each of these. Each neuron is connected to each of the other neurons. Okay, and then you reconstruct it back. Since output variable is not known. Here, since output variable is known, you need not reconstruct it back. And when you try to reconstruct back, the reconstructed could be, it could be image, it could be the text or whatever be it, it will not be of the same clarity as that of your input. Your input and output, the clarity will vary. Here it's not of good clarity. So let me choose this. So we have autoencoders. You take an image and then you supply it to your autoencoder. This is the input layer. You have a hidden layer and you have an output. When you supply it, your hidden layer will learn certain features and then you reconstruct it back. How can I use it? Might be a question. So how can you use it? Let me tell you. When you take your input image, images or text, etc., might be very lengthy, right? It might have high dimensions. The high dimensions means a lot of data, lot of pixel values, or a lot of words, etc. You take those and supply them to your hidden layer. Usually when it comes to the hidden layer, you use less number of neurons. And then you try to reconstruct the same input. Because there is no output, right? Autoencoder is unsupervised learning technique. In unsupervised learning technique, you'll not have the output variable. So how does your model learn weights in that case? Weights are nothing but the patterns in your data. There should be some loss function to be able to come back and update the weights. So you're using the same inputs as outputs also. So you pass through your network, calculate the output. Okay, and then go back and update your weights. You keep doing it on and on and on and on until you get the minimum error possible or until the number of iterations are exhausted. And then what you do is you take these inputs, these hidden layer values representations, and use it for your maybe multi-layered perceptron, etc. This is exactly what we have done for the cancer prediction model. Okay, for the cancer prediction model, this is exactly what we have done. So we have taken the data, we have supplied it to the hidden layer, and then finally you get an output. Hidden, I mean, the cancer images were very, very large, extremely large. Radiology images and pathology images were very large. So if you have such large images, as I've told you, one image was 1.5 GB. Imagine the number of pixels those images would have had. Dealing with such large data would be cumbersome. So we passed it through autoencoders. We captured the intermediary layers details, and we use that on CNN, right? Or whatever network you run, you can use that. And then you finally get an output. So this data will be much, much smaller in size in comparison to the original data. And it will make your processing very fast. Okay. Unlike your algorithms, which are like your zip algorithms, WinRAR, wherein you compress the files. Okay, you zip and unzip. When you zip it, say you have bunch of documents and there is one text file with the password details. When you zip it, and on the other side, when you try to unzip, you don't want any distortion even in a single character, because these are passwords, they are sensitive. You cannot, lose anything. So these kind of algorithms are usually called as lossless algorithms. Okay, these are called as lossless algorithms. On the contrary, if you use autoencoders, what you do is you take your input, you encode it, and you learn the representations. Then you decode it on the other side. And when you decode it, you try to get back your original image, reconstruct it back. Here, the original image and the reconstructed image will not exactly look the same. They will not look exactly the same. There'll be some distortion, some loss. Hence, this autoencoder is called as lossy algorithm. While your zip and etc., they work on different algorithms. They are called as lossless algorithms. Next, if you have MP3 format, it's going to achieve some compression, right? It will work extremely well on sound. JPG also does an amazing compression, right? You have certain lossless compression techniques. These are all lossy. Just a moment, sorry. One second. Okay, and then we have deep auto encoders. I think we have discussed these things, right? Can you just quickly throw some light on this, people? We discussed this, right? Auto encoders. Can you please respond over the chat window, everyone? Sorry, I thought we haven't discussed. So I'll skip this basically. Then I will go to the next thing, which is called as RBMs and deep belief networks. I thought that I haven't discussed these. Okay, and since we discussed about this generation, automatic text generation, etc., maybe I will just switch to GANs and then I'll come back to this. Okay, first let me switch to GANs and we'll discuss about GANs. Generative adversarial networks. Even before I go there is a technique called as deep dream. Okay, there is a technique called as deep dream. Deep dream is all about modifying your images. So it is going to take your image and modify your image in a different manner. Like, I mean, a simple example is like this, what you're seeing. GANs also does more or less the same thing. And this deep dream started giving, a lot of aesthetics to the image. For example, deep dream images. With that, this is how it will show up. Those kind of marks that you're seeing there, as if it's a kind of dream, right? That you are dreaming. That's how it would appear. Your original image is changed to a very great extent with all these marks. That's the application of deep dream. This is just for some kind of fun that people use, okay, to generate beautiful images. And yeah, so what your techniques do is, like, there is something called some other technique also, which is called as neural style transfer. Neural style transfer. In addition to this deep dream that we have, there is something called as neural style transfer. And this has undergone a lot of changes. So what it does is, it will take your original image and it is going to combine this with some other style. So for example, say you have an original image which was taken in France, but you want this to look as if it was taken in a different location altogether. So what you do is you take a different style of maybe Switzerland, maybe some kind of Swiss image, and then you'll try to overlay Swiss image on top of France, and then you get a combined image. This combined image will take the characteristics of this. Okay, typically when I say style, I'm speaking about the texture, color, some kind of patterns, and then you're going to apply onto your original image. This is also done in textual generation, text data also. So this is called as style transfer. You're taking your input image, you're taking another style, you're passing on that style to the original image, and that would be your output. Okay, this is another thing which people extensively started using. Then came in variational autoencoders. Variational autoencoders. What we do as part of variational autoencoders and GANs, right? So first we will discuss about anything, but say variational autoencoder. These are the techniques which are used wherein you're going to convert the image to a different format altogether. You can not just deal with images, you can deal with sound, you can deal with music, you can deal with text also, right? These two techniques. Can we apply to any of these? The main idea behind this is that you take your image and you come up with some hidden information about this. That's called as latent space. Latent means hidden. Some hidden data, some hidden patterns you take. And then it can be mapped to a realistic looking image. So this image horse, if you see here, that is getting completely changed to a zebra. So variational autoencoders, what it does is it will take an image and it will come up with an output image, okay, using a technique called as decoder. Decoder in terms of variational autoencoder. And when it comes to GANs, it is called as generator. Okay, so it will simple. It will take an input image. It will learn some interesting hidden patterns, and those hidden patterns will be applied onto another image and you get an output. GANs and variational autoencoders are two different strategies. VAEs work on a different strategy, GANs work on a different strategy. Okay, this is something else that people are using for just fun purpose majorly. Majorly variational autoencoders is used for fun. Okay, we will take a break, and then post break when we start, I'm going to explain you more about GANs and variational autoencoders. Okay, so let's take a quick break and let's be back by 12:50. And at 12:50, I'll walk you guys through in a better manner. Yep. So let me quickly look at the question. Please remove restrictions in last 1 day so that members may network with each other. Yeah. Yeah, I think we can do it, Srinivas. But then again, the challenge is that too many, irrelevant discussions happen, and people were leaving the group. A lot of them complained to me saying that, do we even need to look at these kind of messages, right? So I would recommend and request you to do a private chat with the people, right? Because the numbers are there, you can do a private chat with them if need be, right? Because we want to retain those groups and keep posting only the related stuff. Otherwise, people will start discussing a lot of irrelevant things. You yourself will become, bored of such things. So that's my recommendation, Srinivas. If there is anything we will discuss over phone, I'm available over phone. Okay. So let's quickly discuss about the variational auto encoders bit, because that will set the tone for our GANs. VAEs are not just used to take the input image, compress the image, and reconstruct the image back. Usually autoencoders do this. They encode, they get the representations, and then they decode it. And you take this internal representation, and it's of smaller size, so compressed format is what you get. You take this compressed format and use it for your further analysis. Okay. The VAE here, this is a typical autoencoder, but VAE behaves slightly in a different manner. What it does is it will take images, for instance, and it will convert the images into parameters. What parameters? It will try to calculate the mean and variance. Once you get mean and variance of the data, then you will assume that the input image is generated based on some statistical process. When you have mean and variance, using that you can come up with a distribution, probability distribution. Okay, so the moment you take an image, the moment you apply encoder on this, it will calculate some statistical parameters, mean and variance kind of calculations. Once you have those, you can come up with a probability distribution. Okay, and then the VAE uses this distribution to get a sample. And then what it does is it will just take different points from this, and it will randomly sample one element. It will decode that element back to your input image. So you take your input image, apply a encoder, and what does this encoder do? From the images that you have, it will calculate the mean and variance. It will come up with a probability distribution, and then you are going to keep sampling the various points. Give it to the decoder, which will again construct back your input image. Right? This is the technique which it applies. The same thing as autoencoder, but the only thing is when you encode and decode, when you use encoders and decoders, it works in a slightly different manner. And the good thing is you can also generate your image which looks very, very different than your input image. Okay, and people usually experiment using Celeb A dataset. Celeb A dataset means celebrity faces. Okay, you have 200,000 celebrity faces which exist. You can take the dataset and certainly, try experimenting all these things. Okay, so what are the kind of applications for VAEs? VAEs are used to do all sorts of image editing. Like if you want to do face swapping, you take a photo of maybe a bodybuilder and you'll replace that with your face, or take an image of maybe an actor and then replace the face with your face. So all these kind of animations can be done. If you have your photo, you can make this photo look like you are smiling, or you can take an image and come up with an image which looks as if you have a frown on your face. So you can do all these kind of things. Morphing is what you call it when you use VAEs. On the other side, you have GANs. What GANs do is they take an image and they are going to generate completely different images. These are an alternatives to variational autoencoders. Variation to this is your GAN. The image that gets generated here using GAN will be fairly realistic. When you use VAEs, it will not look very realistic. But here, when it comes to GANs, it looks very realistic. Okay, so this is all about having two things. One is called as Forger network. You'll have something called as Forger. And then you'll have expert network. Expert network. And each are being trained to defeat the other. So it's something like there is a forger. Forger means the guys, people who do malpractice, forger. Okay. And say this forger wants to come up with a fake image. He wants to do a fake painting and sell it. Do you know what? Recently that has happened, right? If you remember, Saudi prince purchased a fake painting. He spent $450 million. And that image turned out to be a fake image, a fake painting. $450 million. Right? And the buyer fooled this guy saying that that's a Da Vinci painting. He actually got fooled and he purchased. I mean, it's like one of the most expensive paintings to be ever sold, Leonardo da Vinci. Now, just imagine on how cleverly that painter would have fooled this guy. That happens. And objective of these companies who conduct these kind of events is to identify such fake images. So the idea of a forger is to come up with a fake image. Say he draws some fake image and then he goes to a dealer. And the dealer could quickly make out on what are the fake things in the image. Again, based on the, dealer could identify what was fake. Then again, the forger goes back and tries to improve upon this fake image based on the feedback received from the dealer. Again, he does some improvements. Again, he goes to the dealer. Dealer again will identify some, fake spots. And again, because dealer is an expert at identifying such fake things. Again, the forger goes back. Again, he does some edits. And each of them, forger wants to fool the dealer. Dealer says, no, you cannot fool me. So dealer is going to identify what's going wrong. So this forger network within GANs is called as generator network. It takes a random input and tries to generate a synthetic image. Synthetic means some artificial image. So this generator takes an input, a random input, and it generates a synthetic image. Synthetic image. Then on the other side, you have this expert network. This expert network is called as discriminator. Discriminator or adversary. Hence generative adversarial network. Hence the name. So you have generator, you have adversary on the other side. This generator, what it does is it will take this synthetic image, okay, and then a real or synthetic image, whatever be it, and then it is going to predict whether this image came from the training data or was it just created by this generator. Was it the real data or was it created by this generator? So the generator network is trained to fool the discriminator, and discriminator job is to identify the fake images. So over a period of time, this will keep generating more and more realistic images, and discriminator makes it impossible for the generator to fool it. At some point of time, generator will create, based on this back and forth, such an amazing image that your discriminator will not be able to identify. Okay, so the discriminator is constantly adapting to the improvements that the generator is doing, and each time generator raises its bar in generating realistic images, your discriminator also will start increasing the bar. And once the training is over, once you complete the training, the generator is capable of turning any point on the image into a believable image which looks exactly the same or looks very, very realistic. Okay, so you take your input image, generate a synthetic image, discriminator, give it to discriminator image. Discriminator will discriminate and say whether it is real image or fake image. And ultimately, at the end of the day, generator will learn from these feedbacks, and generator will be able to generate such an image which looks exactly like the real image. This is how it works. And then you have varieties of GANs also. Okay, so you take a random data, give it to your generator, that will generate a fake image. Okay, you also have the training data and the data which you have. Supply both of these to your discriminator. Discriminator will look at this and then figure out which one is fake and which one is real. It will learn about both real as well as fake. Okay, so generator generates the fake images. Discriminator will identify whether the generated image is fake or real. Why do people use GANs? Because do you know what? We don't have sufficient number of labeled training data. So people use data which is generated, image or auto synthesis, right? So it will generate the data for you. Why is it called as adversarial? Because it's a competition between two networks. One network is called as generator, which will try to replicate the real data to produce fake. And on another side, you have discriminator, which distinguishes the real data from fake data. Okay, the loss of the discriminator is sent as an objective function. So you'll have generator, discriminator, whatever loss function you get, you go back and update your weights. This process will continue on and on. So initially it is very random, too much of noise. Slowly and steadily your model will keep learning, and ultimately it is going to produce a network which will appear as if it's generating real images. Okay, so GANs have the potential of generating amazingly realistic images. Same thing. You have the hidden some random variable, give it to your generator. It might generate some nonsense, right? It might generate something which is not even fit to be called as an image. That's fine. In the initial epoch, that is how it looks like. And you take your real world images also and supply it to your discriminator. Discriminator will then identify whether it's real or fake. Then discriminator also might go wrong. Based on that loss, you come back and update your weights. Keep doing it back and forth until there is no problem at all. So how do you do this? You define a problem, define your network, train the discriminator with real images and fake images. Train the generator, let it synthesize the data and create the images, and let your discriminator distinguish on whether it is fake or not. And discriminator uses categorical cross entropy or some cross entropy, basically not categorical but cross entropy, binary cross entropy, because it should classify whether it is fake or not. Then it's the same stuff. It is binary classifier, whether it is real or fake. That is what you want to classify. Loss function. Okay. You also have something called as DC GAN. DC GAN is deep, you know, convolutional GAN, generative adversarial network. Here, what you do is, instead of using some MLP, multi-layered perceptron, you use your CNN models, convolution layers. Okay. That's it. That is the reason why it is called as deep convolutional generative adversarial networks. We also have something called as conditional GAN. By using certain conditions, it will decide on whether the image is fake or real. Then you have something called as info GAN. Even if you don't have the output labels, it will start learning. Then you have something called as Wasserstein distance GAN. Okay, this is another. I mean, these are all the various varieties. You have attention GAN, and then that's about your GANs, generative adversarial networks. Okay. Of course, I'm not going to get into the thorough depth. The reason being, it's not needed, and we also do not have so much of time. It's out of scope, kind of. Then you have reinforcement learning. Okay, this is yet another thing which exists. I don't think we'll have time to go through reinforcement learning or Q learning. Can I complete something quickly? And I don't think so, right? So reinforcement learning or Q learning is something which is picking up off late in a very big way. And like you have data mining, supervised learning, and data mining unsupervised learning, you also have reinforcement learning. Like you have supervised learning and unsupervised learning, we have something called as reinforcement learning. This reinforcement learning is a new branch which has come to light of late. It is a neural network algorithm, but it works in a different manner. It is majorly used for games. If you want to come up with some kind of computer games, this is heavily used. And I've at the start shown you something called as Atari Breakout. And I've shown you this. This is nothing but, let me skip it. A classic example of your Q learning. Q learning is a specific form of reinforcement learning. This algorithm will play Atari Breakout. Yeah, so this I think I've shown you, but then watch it again because this is a kind of reinforcement learning. After 120 minutes of training, it plays like an expert. So this is what we will discuss tomorrow. Okay, and then there are a few more algorithms which we will briefly discuss upon. After 240 minutes of training, it plays like an expert. It also learns the strategies on what strategies should be employed to ensure that um, you actually win the game. These are the kind of things which reinforcement learning is very good at. So tomorrow we will discuss about RBMs, DBMs, reinforcement learning or Q learning, and we will I'll have to explain quickly about a few things since we have a good number of people. Let me see if there are any questions. I think there are no big questions. When the Python class starts, I'll look at your questions once again. We will discuss about images, video also tomorrow. Oops, I think our team has responded. Off late, there are a lot of questions which were asked. Okay, now let me quickly tell you that we are going to share with you a registration link. Okay, this we are going to share today and also tomorrow. Why? Because we want to double confirm on whether you're attending the sessions. Of course, we look at the attendance sheet, how many people attended here on YouTube live, all that we will cross check, because here you might not find everyone, but ultimately at least as many people as people attending on webinar jam are attending using YouTube live. So we will be sharing the link. Enoch, can you post the link? Please share your details and the way you want your name to appear on the certificate. And that certificate will be placed on our learning management system here. You need to click on this and then you will get two links to give you for you to give reviews. Please give the reviews. Tomorrow we will explain step by step and then you will be able to download. We are going to start it alphabetically. And this distribution of certificates will take at least 15 days. Why? Why can't it be given immediately? Hold on, please. We don't want a system to crash because it's not just you. People from across the planet are attending are using our learning management system. We don't want our system to crash. Hence, we will slowly and steadily be releasing the certificates to 100 people or so. Okay, so you'll have to click on this, give you the reviews, and you'll be able to download. After you download, we don't want you to keep that certificate with you and not let the world know. One amazing forum would be LinkedIn. The moment you share, it is going to reach a lot of people. So what I will also do personally is, let me open and show you what I usually do. I will go to the posts and activities and look at this guy who has posted the certificate. Okay, and I'll not go here. I'll go to my posts because I usually do not post. And we have tie up with UTM, which is ranked 187th globally. Okay, we have a lot of diploma programs. So this person has shared the certificate. Do you know what? How many people have viewed it? 11,269, because I have 20,000 plus followers, and when I like or share, it is going to reach a lot of people. So you will get that free visibility through me, provided you take that certificate and post it on your LinkedIn profile. Please don't keep it to yourself. Okay, if you keep it to yourself, how will someone come to know that you have actually undergone this training? Let everyone come to know. There'll be new opportunities that might open up for you. Who knows? Okay, and next, about the Python free training, free programming. We are going to start it from 3rd of August. 3rd of August, and it will be from 7 p.m. to 8 p.m. Right? Daily it will happen, and it will be for 1 week. 3rd, 4th, 5th, 6th, and 7th. And we are going to have many such programs. People who attend this will be again invited for another free program on Python, next level of programming. But will we share it with you? Yes. Where will we share? On 2 forums. One is very clearly on our LinkedIn profile. Where will we post it? Let me share that link with you all. We'll go here, and then we are going to post it here. So I will share this link. All you need to do is just click on this follow, and you would be able to see that. Let me post it here. In Vizag also we have institute. Yeah. So I just ping that link, do that, number 1. And on the sticky note, we have already shared the certificate link. You please click on that, and please register. Yeah, it's there on the sticky note for the certificate. It's there on the sticky note. Please register. And the name which is given there will be taken as final, because we don't want any name conflicts at a later point of time. And if you want to know about our Python programming session, we will be posting it simply on our LinkedIn. That's it. I don't think this will work. So let me pick like this and see whether it's going to open up or not. Okay, and then just click on this to be able to view the posts that we have. So you just need to click on this. And I'm once again posting it. Yeah, Enoch has posted, I think. In the message, yeah, we sent it. So that is how you can attend the free Python session. If you don't follow, then probably we might not be able to share. That's one thing. And then another thing is, yep, I think that's good enough. I think we anyways will share my details, and then you can connect with me. So certificate registration is given, details. Please register on this with your exact name. And here is a attendance link. Yeah, thank you, Mallikarjun. Yeah. AP State Skills Development Corporation cert logo would be there. Thank you, Sri Lakshmi. Yeah, thank you all so much, friends. So couple of things you have to do for attending the free Python training. Okay, and for certificate, please register. Python session details will be posted on LinkedIn. You can use GVN. You can use. Thank you. It will be there. Registration details will be there on LinkedIn, on our page. Yep. Thank you, Chakrapani. Thank you, Anila. We will stay in touch, Regina, right? So through WhatsApp or through social media, we will stay in touch. Yeah, I'm super active, Sumalata, on social media. Okay, on LinkedIn, I'm there always. So you can just post your query, I'll respond. Yeah, amazing. Sure, Badrinath, we shall do that. I'll take that as a feedback. No, it will be posted on 2nd or so. Yeah. Do stay with me, stay in touch. Tomorrow is the last day. Please attend, and tomorrow, we can take it further. Yep, absolutely. You can contact me. No worries. Thank you all, friends. It's really a pleasure to be interacting with you all. No, Sampath, you will not be able to get, but contact us separately. We will see whether we can help you. Yeah. Thank you all, friends. Thank you so much. Thank you. Thank you. No, Raghavendra. It is through 360, not through AP State Skills Development Corporation. The Python training. It will be difficult, Dilip. We will try to post it, but it will be difficult. Please follow our page, and then you will get to know the details. Swapna, my details are. Yeah. I think I pinged, and then. Sure, Badrinath. Let us see how best we can do it. We are anyways coming up with a book, so we will be putting this also in that. Maybe it'll be helpful. Yeah, thank you, Kanaka Kumari. Rajendra, Python free program registration link would be shared on the social media. Okay, certificate link is posted on the chat window also. Yeah, it will be posted on my LinkedIn page also. Yes, Balaji. We will see, Manikanta. You just mentioned. We will see how we can support you. Yes, Sheikh, I'm absolutely available on social media. You can contact me and then I will immediately respond. Thank you. Thank you so much for your overwhelming responses. Thank you all, guys. Thank you all.